Hello, everyone. I'm Frank, and welcome to episode 38 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and break them down into detail so that you can learn how to Sudoku. Today's very easy puzzle is called From Rochdale by Burger Mason, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Along green German whisper lines, adjacent digits must differ by at least 5. So therefore, if, for example, if this were a 8, this would have to be a 1, a 2, or a 3, because you can only have neighbors on the green German whisper line can only have a difference of 5 or more. For each blue region sum line, digits on the line have an equal sum n within each box it passes through. So, for example, these 4 cells have to sum to the same sum, as these 2 cells do, right? Because for each region sum line, the digits another way of putting it, which I think I prefer, is that box borders divide a region sum line into regions which must sum up to the same sum. So basically, since this box border divides this line into these 4, into these two cells, these 4 cells must add up to the same sum as these 2 cells. Similarly, for this line, region sum line, the box borders divides the line into the region of these 2 cells and a region of this singular cell. So these 2 cells must equal what this cell is. And that's an example here would be like 3, 5, and 8, right? Because the box borders divides the region sum line into 2 regions. One specifically that has these 2 cells, which is 3 and 5, and this region, which has only 1 cell, which is 8, and 3 and 5 sum up to 8, which 8 also sums up to. And that's how region sum lines work, and those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. So let's learn how to Sudoku. Okay, so for me, the simplest way of explaining how I usually approach things is I usually like to look for things that tend to narrow things down a lot. And actually, German whisper lines are usually a very good way of narrowing things down. Because on a German whisper line, you know that it will always alternate between a low digit and a high digit between neighboring cells in the on the line, right? Because the reason you know that is take a digit that's from 1 through 4, which we consider a low digit. What's the least that number can be next to? What's the least digit that number could be next to? Well, if you take the least digit, which is a 1, and you add 5 to it, that means it's 6 or higher. Has to be next to the lowest digit, right? So that's the lowest digit possible that can be next to a 1 through 4. Well, similarly, if you take a digit that's from 6 through 9, which we consider a high digit, what digit is the highest that can be next to that 6 through 9? Well, if we take the 9 digit as the highest, then you subtract 5 from that, you know that 4 and below is the highest. 4 is the highest that you can have next to a 9. And you can have, obviously, anything that's below that be next to the 9. So therefore, next to a 6 through 9, you can only have a 1 through 4. So therefore, you can always alternate between adjacent digits on a German whisper line so that it will be part of one set or a second set, right? You always alternate between one of 2 sets. So we can just basically target, we could just randomly say, hey, we're going to designate this set as a certain set. So let's designate this set as orange. And we're going to designate this set as yellow. And our sets are going to be orange and yellow. So therefore, what's next to a yellow? It has to be orange. So both of these two are orange because they're both adjacent to it. This has to be yellow, obviously, and these have to be yellow because they're adjacent to an orange. This is adjacent to a yellow, so it's orange. This is adjacent to a yellow, so it's orange. Same here. This is adjacent to a yellow, so it's orange. These are adjacent to an orange, so therefore this is yellow, and this is yellow. Well, this is adjacent, these three are adjacent now to yellows, so therefore these are all orange. These are adjacent to oranges, so they're all yellows here. And these are adjacent to yellows, so they must be orange. Right? One thing that helps us with is we can figure out how much of each set is on a certain, how do you say it? How much of each set is on in each row and column, right? Because you can have at most 4, obviously, of each set in a row or a column. So what I would probably be trying to do is look at areas where you cannot have certain sets, right? So the interesting thing here is one's usually with 4 or 3 of a set, right? Well, this column already has 4 of the orange region, so it cannot have any orange cells here. So this is either 5 or it's a yellow. We're not sure which. So this could be 5, or it could be a yellow. We're not sure quite which one. We're going to make the pink a 5. So this could be yellow or pink. Now, what about this? This is interesting, right? Because it cannot be 2 yellows here, right? Because we have 3 yellows already in column 5. This can't be 2 yellows either, right? Now, what does that tell us? Not particularly much, but it does. This is important, actually. This can only be 1 yellow at most. So that means it could be 1 yellow, and it could be an orange, or it's 1 yellow and 1 orange. Wait, did I say that right? It could be yellow or a pink, which is 5. And again, okay, so 5 can never be on a German whisper line, because if you take 5 away from 5, it goes down to a 0 or less, which could be next to a 5, which is not a normal Sudoku digit. And if you add 5 to a 5, you can get 10 or more, which is obviously not a digit. So therefore, 5 can never be on a German whisper line. So it can't be any of these 5 cells to be a 5. The 5 could be here, and you could have a yellow with a 5, possibly. Or you could have a yellow and an orange. If you have a yellow and an orange, it obviously cannot add up to 5, because any digit that's one set has to be greater than a 5, right? One of them has to be at least 6 through 9, which is greater than 5. So this can never be 5 in that instance, if this is yellow and orange. But if this is yellow and pink, which is a 5, it can also not be next to a 5. Therefore, this has to be yellow. I guess, wait, okay. Sorry, I jumped ahead one. There's also 3 digits in box 5, which are all orange. So this can never be double orange. So you can never have 2 oranges adding up to another digit. So you know it's either 1 yellow and one orange, or it's one orange and one pink, 5 in other words, or it's one yellow and one orange. Did I already say that? Let me go through it again. It's either a yellow and a 5, which is the pink, which would be greater than 5, so it could not be pink to add up to it. It's either yellow or orange, because it cannot be 2 oranges, because we already have 3 oranges in box 5. So it could be yellow or orange. And it obviously can't be 2 yellows, because we already have 3 yellows in column 5. So it's either yellow and a 5, adding up to a digit, or which would then add up to a yellow, which is interesting. That's not possible if, okay, so assume yellow was a low. If yellow was a low digit, you would have a low digit plus 5, which would equal a low digit, which is not possible. So it cannot be yellow and a 5. This therefore has to be yellow and an orange specifically. To add, I guess it could be orange and 5. Yeah, that's one thing I forgot. One of these is orange, though. It can't be yellow and 5, because then that would be great. If yellow is high, that would be greater than a digit, right? It would be 6 plus added to 5, which would equal 11. So that would not be a valid digit. If you had yellow and orange, if you had yellow and a 5 added together. So that's not possible. So it's either orange and a 5, which would add up to a high number in yellow, or it's yellow and an orange, which would also add up to something that's greater than 5, which would be a high number. Therefore, yellow has to be a high. So all the yellows have to be high because of that, right? Because we know that this can't be 5 anymore, right? Because if it were 5, the problem is that you would have to have essentially a different digit, but it can't be. We know that the oranges specifically have to be, can only be one of the digits, and then you would have to have another digit, which would be 6 or higher, assuming that the oranges were low, or assuming oranges were high, it'd be 6 and higher, but then that would add up to a low digit, which doesn't work, right? I hope I explained that well. Probably didn't, because I went through that process again. Okay, let me maybe just use as an example. Say that all the yellows were lows. If all the yellows were low, how can these two add up to this digit? Well, you can't have 2 yellows here because there's already 3 yellows in that column. So you could only have a yellow and a 5, or a yellow and an orange, or an orange and an orange, but 2 oranges add up together, if assuming that the yellow is a low, would mean that you have a 6 plus added to another 6 plus, which is at least 13, which is not a digit. So therefore, this cannot be 2 oranges, assuming the yellow is low. You could have potentially 2 yellows that would add up to a 5, but that doesn't work because we can't have 2 yellows here because of the coloring, right? We know all of these are the same set. So assuming that yellow was low, well, what if we tried yellow and 5? Well, that's obviously a high digit, and we know this can't be an orange, so therefore this never works if yellow is low, essentially. And that's how we sort of limit things there, right? So therefore we know yellow has to be a high digit, because we know that orange, you can't have 2 oranges add up to a yellow, because we'd have too many oranges then in box 5. And this is the convention for numbering boxes, is from typical Western reading notation, which is from left to right and from top to bottom. So obviously this box would be box 1, this box would be box 2, this box would be box 3, then we have 4, 5, 6, 7, 8, and 9. So in box 5, this is obviously box 5 because it's the middle box. We know that one of these, it could be a low with a 5, or it could be a low with a high. But it cannot obviously be two highs because that doesn't add up. And we can only have one low there at minimum. And it has to be here, I think. Right, because you can't have 5 and a high add up to a high digit because that would be 5 plus 6 at least, which would add up to 11, which is not a digit. So the last low in box 5 has to be one of these two digits, and it's with a high. Or sorry, it's with a high or it's with a 5. We're not sure. So one of these is low, which means none of these can be low. So it's either high or it's a middle digit. We're not sure. And this could be high or a middle digit also. Either way, if you have a low with a 5 or a low with a high, you'll always add up to a high digit. Because you can never have, you can only have two low digits add up to a 5. So this can't be a 5. And again, these remaining have to be either a red or pink in column 4, or red or pink, and the pink designates a 5. One thing about these region sum lines, though, is we know these two have to be the exact same digit, right? Because the box borders divides this region sum line into two regions, each of one cell in size, and therefore they must sum to the same sum, and therefore they must be the same digit. So similarly here, this adds up to the same as this one. So this is, let's say that's B, but the B could actually be the same as the A. We're not sure though. Yeah, so this is ways that you can use the principle of the German whisper line, where you basically alternate between two different sets for you. It helps you essentially limit things, right? And that's the whole point of a lot of these Sudoku puzzles, is just limiting possibilities here. In addition, we have region sum lines, each which have one digit equaling the sum of 3 unique digits, right? These are unique digits, and these are unique digits, and there's 3 of them. And they have to add up to what one digit is. So therefore, we know this digit has to be 6 through 9, because if you take the minimum amount, it's 1 plus 2 plus 3 of 3 unique digits. And so therefore the minimum here is a 6. So we can color this essentially as a high also, because we know it can only be 6 through 9. And similarly here has to also be 6 through 9. So this is also a high digit. Well, we now have 4 high digits in row 4, which eliminates a high digit from ever being in the rest of the row. So therefore, this is either a low or 5, and this is also a low or 5. We're not sure which. So this has to be 1 through 5. This is a low, so this is 1 through 4. And we're not sure about this one. Okay. What else do we know? We know at least one of these is a low, but we don't know if it's both or which one. We have 4 highs. We have 4 highs in row 7, which eliminates any high from being in the rest of the row. So this has to be a low or a 5, and this is a low or 5. So therefore the B is a low or 5, so B cannot be the same as A. we know one of these three cells is a 5. We're not sure which, though, right? Because this can't be a 5 because this has to be the sum of at least a low and a 5, which obviously can't add up to 5. And it has to be a high. And there's a German whisper on every other cell. So obviously this can't be, these can't be 5s either. Okay, let's see. What else do we look for? We only have 3 high digits in row 3, so that doesn't tell us anything, unfortunately. What else are we looking for? Well, obviously these have to be 1 through 6, right? Because the most you can have with 3 digits adding up to another single digit is 1, 2, and a 6 as the highest digit, right? So this could also be 1 through 6, but we're not sure about that. This cannot be 5 or 6 because this is a low digit. This has to be a high digit. This is next to 2 unique digits on the German whisper line, so therefore it has to be 7 through 9. Because 6 can only be next to 1 unique digit on a German whisper line, which is 1. This is next to 2 unique digits on a German whisper line, so it's 1 through 3. This is next to 3 unique digits on a German whisper... Sorry, 2 unique digits on a German whisper line, because it's just these two. This one could be the same as this one, so therefore this is 7 through 9 also. This is next to 2 unique digits on a German whisper line, so this is 1 through 3. And this is next to 2 unique digits on a German whisper line, so this is 7 through 9. Well, this is also next to 2 unique digits, either these two or these two on a German whisper line, so therefore this is 1 through 3. And similarly, you can't have... 4 can only be next to 1 unique digit on a German whisper line. So therefore, it can't be any of these low cells. Well, we have a 1, 2, 3 triplet now and actually, well, since we know these two are the same, this is next to 2 unique digits on a German whisper line, so this has to be 7, 8, or 9, which means this also has to be 7, 8, or 9. Well, we have a 1, 2, 3 triplet in row 4, and we have a 7, 8, 9 triplet in row 4 also, which means that 7, 8, or 9 cannot be in the rest of the row, and 1, 2, and 3 can't be in the rest of the row. So this can't be 1, 2, or 3. This can't be 7, 8, or 9, which forces this to be 6, and this has to be 4 or 5, because it can't be 1, 2, or 3, 7, 8, or 9, or 6. Well, this 6 means that these 3 digits have to be 1, 2, and 3 exactly. So these are exactly 1, 2, and 3. These are both low. So I'm coloring these so that I can have a visual indication of what things are where, right? So this is a 6. This has to be at least 1 and 2 added to 4. So therefore this can't be 6 either. So it could be 7, 8, or 9. These are all low. We have a 1, 2, 3 triplet in box 1, which eliminates 1, 2, and 3 from the rest of the box. In addition, this 6 eliminates any cells here from having a 6. And this can't be a 6 again, because it's next to, it adds up to at least 1, 2, and 4, which is 7. This can't be a 6 because it's next to 2 unique digits on a German whisper line. So where's the 6 in box 1? It has to be one of those 2 cells. Okay. This digit is next to is next to two unique digits on a German whisper line. So this can't be a 4 either. This must be a 1, 2, or 3. Therefore, we know this is at minimum 4 and something else. Well, what can that something else be? It's at minimum 5. So therefore, and that adds up to 9 exactly, which is the maximum this digit can be. So therefore, this minimum, 4 and 5, must add up to exactly what this is. So this is 9. So therefore, this is the pink then and the low, which means these are two high digits. This can't be a 5, obviously, and this can't be a 9. Well, we know that this digit is next to two unique digits, but it does not have to, it cannot have a 9. So at minimum, you'll have these digits, or sorry, at maximum, these digits will be 7 and 8. Well, 3 cannot be next to a 7, though, so therefore this can't be 3, which means the 3 in box 5 has to be one of these two cells, which means this can't be a 3. And this is how we limit things. Okay, where is the 6 then in box 5? It has to be one of these two cells because it can't be here. This can't be 9 anymore. Let's see. This is 4 or 5, so this can no longer be 6. Actually, this can't even, neither of these can be 4 or 5. Because if they're 4 and 5, well, that adds up with 4 and 5 to add up to 9, but you have an additional digit here. And therefore, this total for these three cells would then add up to at least 10. So this can't be 4 or 5, and this can't be 4. So this is also a low. We're not sure which. This is a high. It could be 6, 7, or it can't be 6. Because if it's a 6, it's next to two unique digits on a German whisper line, which is not possible for a 6. So this has to be 7 or 8. Therefore, we have a 7, 8, 7, 8 pair in column 3. That allows us to eliminate 7 and 8 from the rest of the column, because one of these two cells must contain a 7, and the other must contain an 8, right? Therefore, this can't be 7 or 8, so this must be 9, which means this can't be 9. This must be a 7 or 8, adding up through 1, 2, and 4. It could be 1, 2, 5, or it could be 1, 3, 4. Either way, the 1 has to be here, right? Because if this is 7, obviously it's 1, 2, 4. If it's 8, it can only be 1, 2, 5 or 1, 3, 4. And either way, the 1 has to be here. So that means in box 4, you can never have another 1. And this can't be 2 and 3. It could be 2, 5 and 3, 4. And those are the only possibilities it could have, right? I guess it could be 2, 6. Okay, so it could be 2, 6. Never mind. But there's no 6 because we have our 6 already in box 4. So this is only 2, 5, and 3, 4. Well, it could be 3, 5. What we know, though, is we have a 1, 2, 3, 4, 5 quintuplet in box 4, which means all 5 of those cells can only contain those 5 digits. Because of that, we know that the rest of the cells in the box cannot contain 1 through 5. And we can't have a 6 here, so this must be 7, 8, or 9. Which means both of these are high then. These are low or a 5. This is a low or 5. The 9 obviously has to be one of these two cells. Therefore, the 9 has to be one of these two cells in box 5. This digit is next to 3 Well, okay, no, it's not 3 unique digits. Never mind. I was thinking something else. This cannot be. This cannot be a 4 because it's next to a 7 or 8 on a German whisper line. So this can only be 1 through 3. Therefore, where is the 4 in column 4? It can only be in the last remaining low cell. So this is a 4. And since 4 is here, it has to be next to a 9 on a German whisper line. Therefore, this must be the 9. So this can't be 9 anymore. This can't be 9 anymore. Again, we know one of these is 3, but we're not sure which. This could be 6, 7, or 8. We're not sure which. And what else do we have? Where is this digit, right? This digit has to be the same as this digit. So where is it in box 6? Well, it has to be in this row specifically because these two eliminate these possibilities for being there. And this is only a low or a 5, right? Because we've eliminated all the other possibilities in row 7. And these two have to be the same. Well, this can only be a low because it alternates between low and high on the German whisper line. So this digit specifically has to be the same as these two. So this is the last digit, and it's an A. We're going to make, well, we already labeled it A, but it's this, whatever this digit is. What's next? These cannot be 9, so they could be 6, 7, or 8. This can't be a 6 because it's next to 2 unique digits on the German whisper line. But this could actually be a 6. And in fact, what this digit is also next to 2 unique digits on a German whisper line, which forces this to be a 7 or 8 because it cannot be a 6, because 6 again can only be next to 1 unique digit on a German whisper line. Therefore, we have a 7, 8, 7, 8 pair in row 7, which eliminates 7 and 8 from the rest of the row. Therefore, this must be a 6 then, because it can't be 7 or 8. This 6 means this has to be a 1, and this has to be a 1, because 6 can only be next to 1s on a German whisper line. Therefore, this can't be 1, this can't be 1. We now have a 2, 3 pair in row 4, which eliminates 2 and 3 from the rest of the row. So this can't be 2 or 3, so it must be a 1. This can't be 1 because it has to be 2 or 3. This can only be, neither of these cells can be a 9. So this cannot be 4. It has to also be a 2 or 3, right? Well, this digit sees both of these digits, and one of them is going to be a 3. And 7 can never be next to a 3 on a German whisper line. Therefore, this must be 8. Now, this is A. So this cannot be A, which means this has to be the corresponding A, right? Because it's the other 7 or 8 here. So this is also A here. This has to be specifically 4, 5, and 7. But this can't be 4, so this is 5 or 7. This is 4, 5. It cannot be 4 or 5 because we have a 4, 5 pair in column 5. Therefore, this has to be a 7, which forces this to be a 5 and forces this to be a 4. So again, this can't be red now because it's the pink, and therefore these two cells can't be pink. They both have to be high. And one of them has to be a 6. So this is 6, 7, and 8 as possibilities here. Okay. So this is a 2, 3 or 2, 3. This is one of them. So it's one of these two. We're not sure which. A cannot... Well, okay, we already knew that. A's here. This is... I don't know. I guess we can label this C. So these are the same. These are the same. And these are all 7 or 8s, right? This is next to 2 unique digits on a German whisper line, so this is 7, 8, or 9 also. Oh. Well, okay, we know... Right, we know A is a 7 or 8. We have a 7 or 8 here. Therefore, in this box, since this can't be... This is next to 2 unique digits on the German whisper line, it could also be 7, 8, or 9, but we have a 7, 8, 7, 8 pair in box 6, which eliminates 7 and 8 from the rest of the box. Therefore, this must be a 9. This cannot be an 8. Sorry, this can't be a 9, so therefore this can't be a 4, which means this is a 2 or 3, but we're not sure which. This could be 1, 2, or 3, because it cannot be next to a 9, and we already have a 4 here, so that doesn't work. Let's see, what else do we know? Well, we have a 7, 8, 9 triplet in column 3, so the rest of the column cannot contain 7, 8, or 9. Therefore, this is 1 through 6, but because we have a 1, 2, 3 triplet in box 1, the rest of the box cannot contain a 1, 2, or 3. So this can't be 1, 2, or 3. This has to be 4, 5, or 6. These are also 1 through 6, and this can't be specifically 4, 5, because there's a 4 and a 5 here. And this is a low. Oh. Okay. Well, we know both of these are high. So the rest of column 6 has to be 5 and higher. So this is 5 through 9, but there's no 6 allowed because this is one of these two is a 6. This can't be 2 or 3 because we know we have a 2, 3 pair in row 8, which eliminates 2 and 3 from the rest of the row. We have a 5, 6, 7, 8, and 9. Well, okay, yeah. What are the rest of the cells in column 5? It has to be 1, 2, and 3. Therefore, this is a low. So we have, this can't be 9 because of this 9. So this is 5, 7, or 8. We have all 4 low numbers already in row 3, which eliminates all low numbers from the rest of the row. So this is 5 through 8. Now, the thing is, these two digits at minimum are 5 and 7. So therefore, it adds up to at least 12. These two digits are at minimum 1 and 2. So that adds up to at least 3. So this is 12 plus 3 at minimum, which means this has to be at least 15, right? Because 12 plus 3 is 15. This has to be at least 15, and it's 2 digits adding up to 15. So 5 can never add up with another digit to add up to 15, because the maximum amount of a digit is 9. So this can never be 5. And therefore, we have a 6, 7, 8 triplet in row 3, which eliminates 6, 7, and 8 from the rest of the row. Therefore, this must be a 5, which means obviously these two can't be 5. What happens if this is an O? I think I see something. What happens if this is... Oh, that's not true. Okay. Well, what happens if this is a 9? If this is a 9, that would mean this adds up to... This is at minimum 1 plus 2 plus 5 plus 9, which is 17. Therefore, these two digits would have to add up to 17. But the only possibility for that would be an 8 and a 9. So therefore, this would have to be the 8, but then this would have to be a 9, which contradicts this being a 9, right? Again, as I said, if this is a 9, that forces these two digits to be 1 and 2. Therefore, this adds up to 17, which would force this to be 8 and 9 specifically, and then you would have two 9s, which would be in the same row, which is not allowed. Therefore, this can't be a 9, which forces this to be a 9 here. Therefore, this is 6, 7, or 8. That's fine. This is the last 7 or 8. Well, okay, this is a 7 or 8 also. We have a 7, 8, 9 triplet in row 6, which eliminates 7, 8, and 9 from the rest of the row. Therefore, this is a 6, and this can't be a 6. This is an A. This is essentially the whatever this digit is. Oh, and we have two unique digits on... Sorry, we have two digits which have to be 7 and 8 in column 7, which eliminates 7 and 8 from the rest of the column. So this can't be 7 or 8, so this must be a 6, which means this can't be 6. Well, now what's the minimum here? It has to be 6 and 9. Sorry, what's the maximum in this digit? It has to be 6 and 9, which adds up to 15. And that's the minimum this can be. So this minimum must add up to what this maximum is, because otherwise if you try going down from here, obviously the maximum can no longer... This is the minimum here, and it can't go further down. And if you try to go up from this minimum, this is already the maximum at 15, and therefore can't go higher. So therefore, this must be the maximum in 6, 9, and this must be the minimum. So this is 1 and 2 with 7. So this can't be 7 anymore. This must be 8, which means this A has to be a 7. So all of these are 7s then. Therefore, this has to be an 8. These can't be 7s, obviously. This has to be an 8. We don't know about this. It could be either one. So this is 8, which means it has to specifically be 3 and 5. Well, we have a 3, 5, 3, 5 pair now in box 4, which eliminates 3 and 5 from the rest of the box. So this can't be 3. This can't be 5, so this is 4, which makes this a 5. This can no longer be pink, so it's a low. This can't be blue, so it's a pink, and therefore this can't be pink. Therefore, this is also a low. This obviously can't be a 5, so it can't be pink. Therefore, we know the 5 has to be one of these two. We're not sure which. Well, 1, 2, and 4 add up to 7, so this must be a 7, and this must be an 8. These can't be 7 anymore, so it's a 6, 8 pair. This can't be 1 or 2 because of the 1, 2 pair already in the box, so therefore this has to be a 3. We also know that we have a 1, 2, 3 triplet in row 2. That eliminates 1, 2, and 3 from the rest of the row. Well, where can the 3 then be in row 2? It has to be one of these two cells because obviously it can't be any of the rest of the row, and it can't be here. So therefore, this is a 3 here, which eliminates a 3 from the rest of the cells in box 1. Therefore, this can't be 3. This is 1 or 2. Well, now where is the 3 in row 3? It has to be here. So this is a 3 then, which is next to an 8, which works. This is a 7. What can be next to a 7 of 2 or 3? It has to be 2. So this is 2. This is 2, which makes that a 3, which makes that a 2, which makes that a 3. This B cannot be 1 or 2. It specifically has to be 3 or 4, but we don't know which. This is also a low number, but it could be 2, 3, or 4. It can't be 3, actually, because of this 3. And we're probably just going to have to do some Sudoku. Okay, well, this can't be 3, because this is a 3, 5 pair, which eliminates 3 and 5 from the rest of the column. This can't be 3, obviously, and this can't be 5. So this has to be a 1 or 2 also, whereas a 3 in box 1, it has to be here. What else are we looking for? This is a 1 or 2 next to a 7, so either of those work. This is also next to, so those all work. The 6, where is the 6 in row 5? These two 6s eliminate 6 from being any of those cells. This can't be a 6 because of the German whisper line. And this can't be a 6 because of this 6, so this must be a 6 here. Which means this is a 3 or 4, because that's the only digit remaining. Only digits remaining in box 6. Okay. Well, what are the remaining digits now in the rest of column 7? It has to be 1, 2, or 5. So this could be 1, 2, or 5. Again, one of these is 6. So since one of these is a 6, this can't be a 6 anymore. So this is an 8, which makes that a 6. These can be 1, 2, or 5, but this can't be 5 specifically because that's a 5. And this can't be 2 because of that 2. What else do we have here? Yeah, we're probably now just doing Sudoku. So the rest of the digits in row 2 have to be 4, 5, and 8. And 8 can't be here. 8 can't be any of these cells, so this must be an 8, which forces this to be a 9, which makes that an 8. That's just normal Sudoku. We have 4, 5, and 6 in the rest of box 1 because of the 1, 2 pair and the 4 other digits that are filled. So this can't be 6, obviously, and this can't be 4. Well, we have a 4, 5, 6 triplet now in row 1, which eliminates 4, 5, and 6 from the rest of the row. So this can no longer be 5. So this is 1 or 2. This would have to be 1, 2, or 7. But obviously, this can't be 1 or 2 because of the 1 or 2 already in the column. So this is 7. So therefore, this is a 1 or 2. And this has to be 4 and 5 in the rest of row 2. But this can't be a 5, so this is a 4, which makes this a 5. This 4 means this has to be a 2, which makes this a 1, which makes this a 2. This 2 means this can't be a 2, so this is a 1, which makes that a 5. This 1 means this can't be a 1. And this is just all normal Sudoku again. So this is 3, 4, 5 here as the remaining digits in row 7. But it can't be 3 or 4 here. So this has to be the 5 then. Which means this is not a low. It's pink. That has to be a low. And it's a 3 or 4, but we're not sure which. The rest of this column is 8 and 9, so therefore this can't be 8 because of this 8, so this is a 9, which makes that an 8. The rest of this column is 3, 4, and 6. This can't be 3, and this can't be 4. This can't be 5 anymore because of the 5 here, so this must be 6, which forces this to be 4, and forces that to be 5. This can no longer be 4 here because of this 4. The remaining digits here are 3, 4, and 7, and this can't be 4 or 7, which forces this to be a 3, which makes that a 4. That's 3 in the corner. We celebrate because we know we're getting to the end. This has to be a 7. This can't be a 3 anymore. So, this can't be a 4 anymore, so this is 3, which makes that a 3 because these are the same, they add up to the same sum, and therefore the same digit. This must be a 4. This can't be a 3, so this is a 5, this is a 3, this is a 5, and this is a 4. Just by Sudoku. Let's see. This can no longer be 3, so this is 6, which makes this a 4. This 6 also makes this a 2, which makes this a 1, which makes that a 2, which makes that 1, that 2 by normal Sudoku. This is a 1, this is a 2. This has to be a 6. And now we're left with 1 and 9. And this must be 1. And this has to be a 9. So, yeah, it's Fairly easy. Yeah, I would consider this also very easy. Um, it was really just figuring out what could be 7, 8, and 9. Figuring out what the highs were, and then basically figuring out what everything else could be along this row. And once you get that broken in, everything else sort of flowed from there. Anyways, I hope that makes sense to you guys, and I hope you enjoyed this solve of this puzzle. And I'll see you next time on Learn How to Sudoku. Take care.